What's up, Warhawks? We're going to talk about 12.2, arc length. So we've talked about arcs. We've talked about one way of measuring them, which is in degrees. Today we're going to learn a little bit different way to measure them towards the end of the lesson. So here we go. So we are on page 924 in your book, and it's got these questions, and we're going to go through them. Basically, it says, is the larger gear similar to the smaller gear? Explain your reason. And yes, all circles are going to be similar to each other. That's just a basic rule. Is the length of the radii in the large circle gear proportionate to the length of the radii in the smaller gear? And it is yes. The lengths of them are proportionate to the lengths of the smaller gear. So, like if I compared OA to EF, it's going to be the same thing as if I compared OB to EG. Alright, determine the degree of measures of the minor arc. Well, since we know that this is a central angle, it's happening at the center, this arc in degrees is the measure 60 degrees. And we know this is also 60 degrees, so they kind of covered. Alright, what is the ratio of degrees measured of the minor arc to the degree of the measures? So, of the entire circle. So we're saying how much of this, this piece right here, how much does it compare to the whole circle, which 60 degrees compared to 360, and if you reduce that, it reduces down to that 1/6. So this piece is 1/6 of the full circle. So degree measure of the intercepted arc in the larger gear is equal to the degree measure of the smaller arc, but do the intercepted arcs appear the same length? So this length from here to here, is that the same length as from here to here? And the answer is no. So if you have a bike and you have one of those mountain bikes, you'll understand that this gear right here is going to turn really fast, and it's really easy to turn because it's smaller. So this length right here is going to be smaller than this length right here. And once you get to the higher gears, it spins. It's much harder to get it to spin, but one spin, one rotation makes you go a lot farther distance. So they have different gears. We use those in cars and all kinds of things to help. And normally you have a smaller gear that attaches to that bigger gear to help push it. So here we go. Arc length is a portion of the circumference of the circle. The length of the arc is different from the degree measurement. So remember when we were saying this is 60 degrees? That was the degree measurement. When we're talking about the length of the arc, we're actually taking like this piece right here and finding that length, not in degrees. Arc lengths are linear measures. All right. So we are now on page 926 in your book. If I'm in a page in your book, it'll be right here. I'm just copying, kind of pasting these things and putting them in there. So you determine arc length by multiplying a fraction that represents the portion of the circumference determined by the central angle and the circumference of the circle. So the formula to determine arc length, S, can be written as follows. So the arc length is represented by S. You take the circumference, which is the distance around the circle, that's the circumference, and you multiply it by that fraction that we found. So in the last example, we said it was 60 degrees out of 360, and we reduced it to 1/6. So that arc length would be 1/6 of the whole circumference. So meaning if the circumference was 36, this would be 1/6 of that. That would be 6 units long. So if this was 36 feet, this piece right here would be 6 feet long. So that's how you find this out. There's going to be a couple different formulas. Notice sometimes they're not going to give you the circumference. Sometimes you're going to have to use 2 pi r. That still represents the circumference, and this still represents that fraction of the portion of the circumference that arc is representing. So it's important to note that the formula implies also that if you take the length of that arc and divide it by the radius, it's equal to m times pi over 180, where m is the measure of the angle. And S over R is directly proportionate to the measure of the central angle, which is m. All right? So let's go ahead and use this kind of stuff, see what we can come up with. So if I was going to do these are a page in your book. I should have wrote that down. I don't remember which one. It's probably like the next page. So flip over in your book. We are on 926. So maybe at the bottom of 926 or 927. These problems. Go ahead and try them on your own. Pause the video. Go ahead and take a minute. Use the formula that we just came up with and see what you can come up with on your own. Just take 1 or 2 minutes to go through them. Okay, I'm going to go to the next slide, which is going to have the answers. So here's how we find them. Notice, you are supposed to take, if this is 80 degrees, I need what is this arc length, which is going to be 80 degrees because it's a central angle, and those are going to be congruent. So 80 over the full 360, that's going to give us our fraction, which is going to reduce to 2/9. Then we need to find the circumference. Well, the circumference is 2 pi r. Well, the r in this case is going to be 10. And when I do 2 times 10, I get 20. So that's where the 20 came up. So we've got 2/9 times 20, which is times pi, which you can write as just 20 pi if you want to, like they did over there. And then when you multiply, the way you multiply fractions is you can put 2/9 times 20 over 1 times pi. Just leave the pi kind of alone. When you multiply a fraction, top times top, bottom times bottom, 40 over 9 pi would be our answer. We're going to leave it just like that. There's no reason to change it. If they ask me to approximate it, then I'll put my calculator, I'll take 40, I'll divide it by 9, and then I'll times it by pi. I should do this a little better. Let me write that better. It should be 40/9, and then make sure the pi is towards the center. So people know the pi is not in the denominator. It's 40/9 times pi. So you would take 40 divided by 9, get that answer, and then in your calculator times by pi. So that's how they got that answer. Same kind of thing they're going to do for the rest of them, guys. That 120 came from right here over the 360, which is the full circle. 2 times, again, this is going to be 10. Now we had 1/3. Remember, 1/3 times 20 over 1 pi. Top times top, bottom times bottom. That's how you get that answer. All the rest of these are going to be the same. They give you the problems to work out. You can pause the video if you want to look at it. If you have questions, you can come up and see me. Just for time's sake, I'm going to go ahead and go on. All right. Next one talks about, this is in page 227. You have 2 semicircles were cut, taken from the rectangular region shown. Determine the perimeter. Perimeter is the distance around. So I would need from here to here, from here to here, but I also need these lengths. I need that measure of that. So here's how they did this problem. I would maybe approach this one a little different than the book did, but hey, we'll go with what they did. So they found the lengths of the sides here. So this is 20. This has to be 20. So 20 and 20 is going to be the 40. That's where they got the 40 from. They then used the formulas we've been using. The measure of this central angle is 180 degrees. It's a semicircle. That's where they got this 180 from right there. They then said 2 times pi times the radius. Be careful on this because this 8 is from here all the way across. A radius is only going to be half that, which is why it's 4. So that's where this 4 came from. You take that, you multiply this out. This is half, so you end up with half times 2 times pi times 4. The halves cancel. You end up with 4 pi. But not only do I have just one of those, I have 2 of them because I have this length right here is 4 pi long. That's 4 pi. This length right here is 4 pi. And remember, the perimeter is from here all the way across. And so that's when they got that 40 plus 8 pi. In their calculator, they hit 8 times pi, then added 40, and they got this answer. You should practice that on your own at home. Do that in your calculator. Make sure you can come up with that answer. All right. So far, we have described the measures of angles and arcs using degrees. A radian is another unit that Sorry. I think Miss Martin went on Spotify and was playing it. We have the same account. That was funny. I don't know why Spotify does that. So, going back to the lesson, because I'm not doing this over again where I spent 10 minutes. So far, and you just got to enjoy a little bit of Star Wars. That's Kai's favorite channel to listen to. He literally just puts on Star Wars and listens to their music. So that was his channel. So far you have described it, so we talked about radians. So 1 radian is defined as the measure of a central angle whose arc length is the same as the radius of the circle. So let R represent the length, the radius of the circle. And this is going to be this new symbol, which this guy over here in this bubble, so nice of him to tell us that that's theta. Okay, so this symbol, anytime you see this, it's going to represent this thing called theta. Represents the measure of the central angle in radians. So this, when you see that, it's going to be represented in radians, not in degrees. Not in degrees. So we can actually take and turn radians into degrees, and we can take degrees and turn them into radians. It's similar to something being taken into feet, taken into inches, and inches into feet, something kind of similar to that. So note that S divided by R is equal to theta. So the circle has a radius R, the circumference of the circle is still 2 pi R, and there are 360 degrees. Because 360 degrees is equivalent to 2 pi R divided by R, okay? Because remember, it's the measure of S, which in this case our S is going to be the whole circle, which is the whole circumference, and I'm dividing it by the radius, which is where this radius came from. The radians cancel out, and so 1 radian, 1 full rotation is going to be equivalent to what is called 2 pi, and this is in radians. So if I went down to half a circle, if I wanted to say how much is a semicircle worth, hopefully you're realizing if a full circle in radians is 2 pi, half a circle would be exactly pi. Okay? So when converting degrees to radians, multiply by pi over 180. When converting radians into degrees, we multiply 180 over pi. So it's very similar to like when I had 1 foot and I wanted to convert that into inches, I would say, hey, 12 inches is equal to 1 foot. And the reason that you do this is because the feet cancel out. Again, here, when I'm going from degrees to radians, I want the degrees to cancel out. So if I have 30 degrees and I want that into radians, I'm going to put 30 degrees over 1, and I'm going to multiply that by pi over 180 degrees. Because, again, I want my degrees canceling out. So that's how I remember it, is that they are across from each other for the one I want to cancel out, and then that leaves that pi, or radians there, allowing me to see that. So let's use this stuff. So here is another example in your book. I believe it's probably the next page. These are problems 1, 2, 3, and 4. Go ahead, take a minute. Try to do these problems. Again, stopping the video and going through these. This is meant for you to try it on your own a little bit, and then we're going to go over some of the answers. So you have time right now to pause it. I'm getting ready to move on. And here are the answers for these. So if theta, remember this is the way we read this, is theta is 2 pi over 2. If theta is pi over 2 and r equals 4, solve the length of the intercepted arc. Okay, so to do this, we know that theta is going to equal pi over 2. So we know that the length of the intercepted arc is represented by s over r. Well, we know that r is 4 in this, so we plug in 4. So that leaves us with the length of the intercepted arc as the only variable, Again, if you remember, when you have equivalent fractions, you can cross multiply, and that's where they got this 4 pi equals 2s. They just cross multiplied. Again, they're going to get this s by itself, so you're going to divide by 2, divide by 2. When you do that, these can cancel out, and this becomes 2 pi. And that's where they got this answer from. So that would be the length of the intercepted arc, and it would be 2 pi. All right? Number 2, if r equals 2, and the intercepted arc length is 5, what is the measure of the central angle? Well, remember, theta, or the measure of the central angle, equals the length of the intercepted arc divided by r. So all it is, they just took 5 divided by 2, and boom, that's my answer. Last 5. Done a good job tonight. At the same central angle theta, if the radians is 6 centimeters, what is the arc length of the intercepted arc? So here we go. We've got these guys right here, which we know are similar to each other because all circles are similar. So if I can do this, what I can say is, hey, this is the same angle here, this is the same angle. So now I'm talking about the same portion. They're going to be proportionate because those two angles are the same. If this is a different angle right here than this is right here, then this proportion will not work. But because they are, I can see 18 compares to 12. Just like 6 compares to unknown. So 6 compares to x. Again, proportion cross multiply. We get 18x equals, and that's going to be 72. Divided by 18. Divided by 18, and we get x equals 4. So the length of this right here would be 4 centimeters long. All right, last problem, then you're free to go. The measure of the central angle is 120 degrees. The length of the radius is 20 centimeters. Determine the arc length using the formula. So again, the measure of this angle is right here, 120. So in this formula, we're going to put 120. That's what they did right here. Took out the 120, and they left 360. Times by 2 pi. 2 pi is the same. All we need is a radius, which is 20. And they just simplify things. When you simplify that, it becomes 1/3. When you multiply 2 times 20, you get 40 pi. And then you take 1/3, times it by 40 over 1. And again, pi is kind of, we leave it alone. We get 40 thirds pi. Remember, leave it as a fraction. We're starting to get to where we can, it's okay to leave it like that. Hope you enjoyed your Star Wars music in the middle of that. I don't know where that came from. Have a great night, guys, and I will see you tomorrow in class.